Welcome to the Explainer. Today, we're diving into a classic six-panel storyboard. Now, on the surface, this might just look like a cute little children's fable about a thirsty bird. But as we're going to see, it's actually a complete masterclass in survival, ingenuity, and applied science. We're going to break down exactly how an everyday animal takes a potentially fatal problem and turns it into a totally brilliant, structured solution. Let's get right into it.
So take a look at this complete six-panel sequence we pulled from our source. Just notice the progression here. We start up at the top left with a crow in mid-flight, move through a pretty frustrating discovery, and end up with a highly calculated triumph down on the bottom right. It's amazing because these incredibly simple, everyday illustrations, they perfectly capture some really complex scientific concepts. I mean, we don't need a massive, heavy textbook to understand fluid dynamics or the scientific method, right? Because literally everything we need is sitting right here in these six drawings.
Part 1. The Dilemma. Water, water everywhere. Okay, so imagine this. After a long, exhausting flight across a clear blue sky, our main character is desperate for hydration, and boom, spots a clear pitcher right out in the open. But, well, that luck runs out almost immediately. Check out the visual evidence in the third panel. We've got this curvy, clear pitcher, but it's only half full of water. Sitting right next to it is a really large gray rock and some scattered, loose pebbles. Now, the bird has landed on the rim, but its beak just can't reach that low water level. The actual geometry of the pitcher is totally preventing the bird from leaning any further in. It is literally so close to survival, but completely blocked by physical barriers. So frustrating.
Which brings us to a huge fundamental question. What would you do here? Really, how can this bird reach the water? It obviously can't break the glass, and if it tries to just forcefully knock over that heavy pitcher to spill the water out, the liquid is just going to soak right into the dirt and be lost entirely. No way that works. It is a true crisis, perfectly framed as a physical puzzle we need to solve.
Part 2. The Avian Scientist. Hypothesis and Action. To figure out this puzzle, we really have to stop looking at the crow as just some thirsty animal acting on pure instinct. Instead, we need to see a methodical problem solver. Notice how absolutely perfectly the bird's next moves map onto the scientific method. First up, observe. The water's too low, the beak's too short. Second, hypothesize. Hey, maybe adding mass to the container will alter the environment inside it. Third, experiment. Start dropping those pebbles in, one by one. And finally, conclude. The hypothesis is spot on. The water rises and thirst is officially quenched. And you know what's truly incredible about this? It's not just a made-up story. Modern scientists have tested real crows in labs, and corvids actually solve water displacement puzzles exactly like this in real life. How cool is that? Let's actually pinpoint the exact moment this massive shift happens. Focus on that bottom left panel, the fourth one in our sequence. This right here is the turning point. Pure observation is turning into deliberate physical action. The crow has this small gray pebble clamped firmly right in its beak, totally ready to execute its experiment. This one single frame is what bridges the gap between just having a theory and actually testing it out in the real world.
Part 3. The Physics of Survival. Displacement in Action.
So why does this experiment actually work? Well, the crow's strategy isn't just clever, it is relying on an absolute, immutable law of mechanics. The secret weapon here is displacement. That's the occupation by a submerged body of a volume which would otherwise be occupied by a fluid. In simple terms, the crow is using the physical volume of those solid stones to literally evict the water from the bottom of the pitcher. It's forcing the water to go the absolute only place it can go, which is up. Let's measure the success of this little physics experiment by comparing the before and after states. Initially, back in panel 3, we had a super low water level, an empty bottom, and a very frustrated, very thirsty crow. But look at the final panel. The dynamic has completely flipped. Now we have a high water level sitting right at the rim, a base that is absolutely packed with solid gray rocks, and a successfully drinking bird. The contrast is night and day, and it is entirely thanks to the bird's physical labor and its brilliant spatial understanding.
Visualizing the volume of the pitcher really makes this whole thing crystal clear. You see, the initial water volume is just a static amount of fluid that never changes throughout the entire story. But as the crow drops those pebbles in, one by one, that added rock volume starts stacking up at the bottom. The math here is super simple. Initial fluid volume plus the added solid volume equals a total combined height that reaches the very top of the pitcher. The water wasn't magically multiplied or anything like that. It was just physically pushed up by the rocks.
This whole sequence just absolutely perfectly embodies that classic proverb, necessity is the mother of invention. I mean, the crow didn't just start dropping rocks into the water for fun, right? The dire circumstance, the absolute life or death necessity of getting hydration to survive, is what forced it into this state of highly innovative, structured thinking. It's such a beautiful reminder of how intense pressure can forge absolutely brilliant solutions.
6. That is the exact number of panels it took to convey this entire journey. In just 6 simple visual frames, we've encapsulated a complete, compelling narrative. Think about it. We witnessed a life-threatening problem, careful observation, the formulation of a hypothesis, the deliberate execution of an experiment using the laws of fluid displacement, and finally, a successful, life-saving conclusion, all in just 6 pictures.
As we wrap up today's explainer, I really want to leave you with a final thought here. The next time you face an impossible obstacle, one of those situations where the water is just out of reach and you can't just brute force your way through it, what are you going to do? Will you just fly away and give up, or will you take a step back, really observe your surroundings, and start dropping pebbles? Thank you so much for joining me today. Keep observing, keep experimenting, and I will catch you in the next explainer.